morning, everyone. I hope you had a good break. You enjoyed some time off to take to have some snacks at least, right? And before starting off, we would really like to thank the organizers for pulling off this great amount of effort and to, of course, organize such a great event. Now, looking at this very title slide, right? It's been quite a year for all of us, I'm pretty sure. 2020 has been quite a year. So let's see together how we can secure eHealth, eGovernment, and e-banking, of course, using our beloved programming language, Java. Before we kick it off, let's have a short round of introductions, right?
Hi, I'm Werner Keil. I'm the current representative for the committers in the Jakarta e-specification committee, and I'm also involved in several open source projects. And I also used the DSS framework that we are going to talk about later, approximately 1 year ago, for some infrastructure for the German eHealth network. So they're actually using that, and I improved it a little bit, especially when it came to jigsaw modularity. So I have also been a contributor to it in some cases. Here's a little bit about ABN AMRO, which Thodoris usually can tell you a little more about, but they're also very agile and migrate. Oh, here's again.
Yes.
Okay.
Can you
share the screen again? I just picked up with the slides about your bank. So if you can just switch to the black slide and
I
just started saying that you're also very agile and you're looking for people. So yeah.
So I guess that's quite an advertisement and promotion, Werner. Thanks a lot for that. Yeah, so basically, if there is anyone interested in working in a future-proof bank, feel free to reach out to me. Sorry, my apologies for having a bad connection. I just turned on my mobile data. With that, let's not waste any more time and let's have a quick look at the agenda for today, right? So, how are we gonna do this talk? We're gonna just start with some very basic introductions of eHealth, eGovernment. We're gonna look at signatures and certificates. And of course, in the course of the talk, Werner will take over after some time once we are done with a very introduction of today's session. And he will also show us some demos on the DSS framework as well. So to kick it off, for today officially, and hoping this will be the last time we faced some technical issues. What is eHealth? eHealth refers to the use of information and communication technologies in healthcare. And of course, this is a definition taken from the World Health Organization. What about eGovernment? Let's read through this definition together as well. eGovernment stands for the opening up and adaptation of the public sector through information and communication technologies. Of course, Werner lives in Germany and I live in the Netherlands. So this is how we created our short introductory examples for eHealth and eGovernment. So what about eGovernment in the Netherlands? Sorry, in Germany. We can differentiate two different flavors of eGovernment in Germany. First of all, internal, where we are using IT within the public sector without any contact with the citizen. And how could that happen? By using, of course, electronic medical records, exchange between public authorities, healthcare providers, pharmacies, and so on. That is only one flavor of eGovernment in Germany, though. What about the second one, which is external eGovernment? What do we have there? So external eGovernment in Germany comprises websites and services for citizens, patients, customers, companies, etc. And now, what about eHealth in Germany? A small remark to begin with is that currently in Germany, eHealth is still at an early stage of the application, of each application, of course. There are, however, some advantages and possibilities. Let's have a quick look at those ones. Starting off with long distance communication, regardless of location, of course, right? So, especially in rural areas or where there is a shortage of doctors, there could be, and there are already some possibilities for eHealth. Second of all, computer-based procedures for the collection, transmission, and evaluation of health data. And third one could be the monitoring of patients, for example, the ones who are chronically ill or voluntarily self-monitoring. An example here could be, I'm just thinking out loud, a very good session Werner hosts every now and then, which is on the quantified self, and where he demonstrates several ways to keep track of self-monitoring about your health. Now, what about
the COVID applications nowadays would also be some case of self-monitoring. And by the way, the German authorities, at least temporarily, also allow additional remote interaction. For example, right now, you can report sick online and you don't have to go to the doctor. So the risk of contracting the COVID disease before you were actually just sick with a flu is minimized. Of course, that's only temporarily, but especially right now. And even the German health minister got sick with COVID recently. So they adapt in some cases more quickly than they had planned before.
Absolutely, absolutely. So what about the government in the Netherlands, though, right? So let's start by having a look at the government with a very different approach. Everything started with eIDAS, right? eIDAS, which is about accessing Dutch government services online. And what does this mean? Of course, it means that the introduction of eIDAS, which stands for Electronic Identification and Trust Services Regulation, means that EU citizens from other member states of the EU can access Dutch government services online. Now, I'm pretty sure you're already wondering what are those services someone could access in the Netherlands. So let's take once again Germany as an example here. You can use your login details for your German electronic identification scheme to access all the same services as Dutch people can do by using their DigiD, we call it in the Netherlands. It is the digital identification service you can find online. So, for example, if you are a German citizen working in the Netherlands, a German national working in the Netherlands, you can log in using, I'm gonna try to pronounce it good, using your Neuer Personalausweis to see what, first of all, to see how much pension you have built up through the social insurance bank. We call it Socialverzekeringsbank in Dutch, to also submit your tax to the Tax and Customs Administration, to check your pension payments to your pension provider, and of course, some more tricky situations like to also object to the assessment of value of your property under the Valuation of Immovable Property Act, the so-called VOZ in the Netherlands. Now, that would be a short introduction with examples about eGovernment in the Netherlands. What about eHealth, though? eHealth in the Netherlands. The government is basically encouraging the healthcare sector to expand telehealth, so eHealth services. There are some goals set by the Dutch government, with the first one of them being access to medical records. To be more specific here, the Dutch government would like to have at least 80% of chronically ill people to have access to their own medical records. By 2019, we've said, let's make it by 2020, as it's been a tough year. And of course, at least 40% of other members of the population. Another aspect of eHealth in the Netherlands is health monitoring, right? Where by 2019, once again, 75% of chronically ill people and vulnerable elderly people should be able to monitor certain aspects of their own health, and of course, to share the data with their provider, with their healthcare provider. What could those data be? Blood pressure, cholesterol levels, whatever might comprise the quantified self, as Werner shows and demonstrates in the other talk. Now, and third aspect of this eHealth adaptation in the Netherlands is, of course, the online contact with the healthcare provider. What does this mean, though? It means that people receiving care and support at home should be able to communicate with their care provider 24/7 via screen, if they wish, of course. Now, I'm pretty sure here comes the question again, how can we achieve those goals regarding eHealth, right? So first of all, there is definitely some support from the government via an online platform, which is called Zorg voor Innoveren. It definitely means healthcare innovators willing to have or to create a new digital application can go to this website, zorgvoorinnoveren.nl, where they can receive support to help them develop their idea swiftly and effectively into a working application, of course. The site also has tips on how to get funding and all this kind of startup spirit. So another aspect or another way towards achieving this kind of eHealth goals in the Netherlands is, of course, by making digital data sharing easier. Because the government is nowadays consulting with healthcare administrators on standards that should facilitate digital data sharing. They are also talking to suppliers of IT systems, of course. Third one, and now it starts to get more interesting, it could be by sharing eHealth know-how. The government is actually bringing healthcare innovators and other parties together. It has established a startup network, for example, which includes healthcare providers, patients, and lawyers. This network basically allows all of those three different parties to share knowledge and help startups and innovations advance to the next stage. Another way to achieve those goals is, of course, by having some personal digital healthcare environments in place, right? Of course, some healthcare providers and IT suppliers already offer patients the opportunity to draw up and manage a personal health record, the so-called PHR. However, safely combining and sharing personal health information is a real complex matter and is currently possible to only a limited extent. Now, okay, we started with quite some data. However, I'm pretty sure there could be a question, what are the real benefits of eHealth, right? So first of all, we can definitely say or claim that eHealth is definitely saving us more time, right? Because patients can schedule their own appointment with their care provider online. There is no need anymore to leave their home if they can arrange an online consultation, for example, via video link, right? Second benefit of eHealth could be the insight into own health. See quantified self once again, where a personal digital healthcare environment gives people more insight into their health. So, what does this mean? If they wish, they can share all or part of their data with a healthcare provider so that they do not have to repeatedly relate their entire medical history. And third one, what was the most important drawback of health administration back in the day? Bureaucracy, right? And of course, I come from Greece, where that is still a burden, or at least I have experienced what bureaucracy stands for. So
Is the word
nowadays,
Greek originally?
sorry?
Bureaucracy. Does the word come from the Greek language?
Yes, it does come from there. However, there are also some good steps having been set in the last 2 years at least. But back to the benefits of eHealth, eHealth definitely helps us to have less bureaucracy. So it definitely helps us towards lowering the administrative burden, where doctors have less paperwork and can share information securely and easily with colleagues, of course. One thing to stress here is that not all healthcare providers currently offer telehealth. There are Most of the healthcare providers, though, are fully aware of the benefits of eHealth. And of course, many doctors nowadays offer patients the opportunity to schedule appointments offline. It is definitely a good start, right? And just for the sake of statistics, around 46% of patients would like to have online access to their medical records. But this can only be done if there are good safeguards for privacy. And speaking of privacy, I'm gonna itch a good scratch now, because there are definitely, when we're talking, about eHealth, eGovernment, there are definitely some requirements for secure transmission, right? So what are those requirements for secure transmission all about? First requirement for secure transmission is nothing else than integrity, where messages should not be able to be falsified unnoticed. Second one, identity, right? A message should be clearly assigned to the sender. Third one, authenticity. The identity of the sender should be verifiable. I'm gonna do the fourth gesture, but we don't have something to say for here because it is confidentiality, right? Where messages should not be read by unauthorized persons. Okay, so 4 main requirements for secure transmission. Authenticity and author of data, right? There is definitely some need to assign the data, for the assignment of data to the signer by protecting against denial by signatory and against manipulation, of course, on the transmission path, but also through the receiver. And yes, it's about time to start talking security, risks, solution, you name it. There is definitely quite some talk nowadays regarding how secure our systems are. And of course, e-communication entails quite some risks, like who is my counterpart? Who is reading? Has anyone changed something? Well, the solution is, of course, e-signature and encryption, where unauthorized parties cannot read an encrypted message, where electronically signed documents cannot be changed unnoticed, neither during transmission nor through the receiver, as we've seen in the last slide, and of course where sender cannot deny text. So what is the solution here? We're slowly unveiling the entire session, right? Electronic signatures it is. And how do they work? How does a typical electronic signature work? Let's read through it together. The electronic signature is a cryptographic method that uses two asymmetric keys, a private key and a public key. The private key is to be kept secret and is actually used to encrypt the hash value of the document. The public key can only be used for decryption and matches only one private key. It can be publicly retrieved and it is often sent with the message. Now, of course, this might sound not that straightforward if you're not well acquainted with security procedures. So let's have a look at this diagram where starting from the top left to the bottom right. So as a signer, we would like to send some data document over the network securely, right? So what are we doing there? We have our data document and we're using a hash algorithm. We create a hash, as we can see here, right? Then, using a private key, we encrypt the data document, which actually creates or generates our digitally signed document. Once again, the private key is to be kept secret and it is used to encrypt the hash value of the document. So hash value is created here using a hash algorithm, which is known to us, and then using a private key, our own private key, we create a digitally signed document. The document is then transferred or transmitted over a network, as always. And before reaching the verifier, how should this verification look like? How should it look like? First of all, using the same hash algorithm that is known to the verifier, the verifier creates a hash, right? And then once again, using the public key, which can only be used for encryption and matches only one private key, the verifier generates a hash once again. And those two hashes should match and should be equal. Otherwise, the signature is not valid and the verifier shouldn't accept the document. Now, I'm pretty sure you might be wondering how to make it happen to make a secure transmission possible using some good signature procedures. There are definitely different types of signatures, which Werner will show you right now. And with that, I will stop sharing my screen so Werner can take over.
Yes, here we go. So there are 4 types of signatures, although the last 2 are only a variation of each other. Simple electronic signature, or SES, an advanced electronic signature, or ASiC. And if you're wondering, no, we are not talking about Greek gods again today, although some of those do sound a little bit like Hades. The qualified electronic signature, and the same with a provider accreditation. They vary from most secure to less secure. So what's an advanced electronic signature? It allows a unit owner to be uniquely identified with that signature. It's generated so that the owner can keep it under their sole control. And it also allows to identify if the data has changed after it was signed. And it can be invalidated, for example, if it's not valid by the end of the year or some other period. That signature can also be held by a company or a service or an application, so it doesn't have to be a natural person, which allows machine-to-machine communication, for example. The qualified electronic signature has additional attributes like a serial number, a reference, the name of the person. So here, usually you would have a natural person, a verification, again, a validity, a certification service where it was issued, and possible usage restriction. That could also be that it's only valid for particular countries or a continent. That's comparable to the area restrictions that you may see with DVDs or with Amazon, that certain content cannot be played outside the US or outside Europe. Adding accreditation makes it most secure. An accreditation provider also has to be vetted. For example, in Germany, that would be the BaFin when it comes to financial transactions and fintechs. And there are others in the healthcare sector. We're also going to see some of those trust centers on the website of the DSS demo afterwards. So what's a certificate? It's an assignment of the electronic signature. It's basically an electronic document linking to the public signature verification key and the name of the holder, which can again be a natural or a legal person. The most common format that you'll probably know from the internet and elsewhere is X509. There are different signature formats. XAdES for XML documents, CAdES for any type of binaries, including images, PDFs, which is specific for PDF, and ASiC stands for Associated Signature Container. There are different ways of packing. Some of them are not possible for every document format. Others work for all of them. We have enveloped, where the signature is put inside the document or the signed element. Enveloping, which is the other way around. So you put the original document inside the signature. Detached, you have a signed element and the original document next to each other. Or internally detached, which is a special variation that's used particularly for XML with electronic health records and similar formats. Here again, this is basically specific to digital signatures, but essentially that's pretty much what Thodoris has already showed you earlier for the general encryption mechanism. The European Union has defined certain domains that benefit especially from digital government and e-government. Of course, eHealth, e-justice, when governments and police forces from different countries, for example, try to work together catching car thieves before they exported the cars to Eastern Europe or Asia or elsewhere. E-procurement or general e-business. We're only going to quickly look at it here, but since there were also several questions in previous sessions we had, of course, eIDAS and electronic signatures are especially important when it comes to e-banking with the so-called PSD2. initiative of the European Union, allowing to open services for financial service providers like banks or shops. And here are the various players exchanging such eIDAS certificate. Now let's have a look at the DSS framework. The DSS framework is an open source initiative and project found on GitHub. It's mainly sponsored by the European Union, although there are also contributors from outside the EU. It allows the creation and validation of electronic signatures. And it's fully compatible and interoperable with the EU legislation. The three most important features are creating a digital signature, extending it, and validating it. It supports all the major formats like XML, PDF, Word documents, or OpenOffice, plain text, or various archives like zip or tar. It supports the packaging mechanisms, enveloping, enveloped, detached, and internally detached, as well as the signature formats like CAdES, XAdES, PDFBox, and ASiC in its variations. You can also apply a profile to a digital signature, trust management, and the revocation data handling, which is if a signature is later revoked or not valid. A certificate chain, so that you can ensure that all the signatures in that chain are valid and uncompromised. And you can also validate the signing certificate. With PDFBox, you can prevent famous PDF attacks. Please have a look at this website. It's by the German Institute in Bochum. They're specialized on things like e-security, and they actually exposed some of those, including the infamous $1 trillion US Amazon refund voucher. So it still wouldn't bankrupt Jeff Bezos, but of course it would be quite expensive. And thanks to PDFBox and digitally signed PDF documents, you can avoid such fraud or also smaller fraud attempts that may otherwise remain unnoticed. Now, let's move over to the demo. We take a brief look . I hope that's big enough. We take a very brief look at one example of signing an XML in XAdES, so you get an idea about the steps. Again, that's all available, especially this DSS cookbook is a very good starting point if you want to familiarize yourself with what's necessary or apply it in your own project. There's also a standalone application that you can download. So I'm not going to run this locally because I already prepared it, or use certain documents that have already been signed, because you do need this Next2 extension to actually do it online. So if you install that plugin, then you can sign the document directly in that website. You can also run the website in your own Java or Jakarta E container like Tomcat. Or use the standalone application, which I just show you here for the sake of completeness. So here, using Java and JavaFX, by the way, this is a JavaFX application. It allows you to select a file, then select the container type, the signature format, how you want to pack it. Then you have to use a token. And after that, you can basically sign it out of the box. So let's look at some examples. First, yeah, obviously, in Corona times, that is a very valid use case when different health providers around the world and hospitals want to exchange data. So here we have a CT scan from a COVID-19 patient in China. This is the case of detached. So I check both the signature object and I provide the original JPEG document. Since this was self-signed, many of these additional safety attributes do not apply because it's self-signed and I don't have a certificate chain. So that's why all of these are yellow warnings. The same goes here with the certificate validation and the chain. That's okay. But as you see, everything else, the basic building blocks, the cryptographic verification, signature acceptance, all of this has a green check mark. So it's a proper signature. There's also an ASiC validation report in XML format that can be processed electronically. Now let's look at one other example. Actually two, I think we have enough time. So here's a PDFBox PDF from Czech Republic, from the samples. As you can see here, there are actually some inconsistencies, again, mostly with the long-term validation and revocation. Most of the others look quite good. And then we take another PDFs that's eIDAS signed. So the only issue here is that the out of bounds is not revoked. So that those are again issues primarily with the validation or how long it's valid. So you see these two that have a few warnings. The current time in the validity range of the signer certificate is cannot be verified, and Since this is also a sample, there's no next update defined for the revocation data. So in a real life scenario with actual signatures and actual signed documents, you would, in an ideal situation, see that every single one of them is green. But since this is sample data, and I think the last time this PDF was provided was 2 or 3 years ago, so especially some of the time-based requirements may not all be fulfilled, but otherwise this is a perfectly valid, qualified electronic signature. So especially here the QSCD and all the other blocks are, except for this one, everything else is perfectly met. So as mentioned, you find the list of trusted providers for all the major countries. So here's Germany, for example, or Greece. This is primarily EU. Yeah, the UK is still there. I'm not sure, at least when it comes to PSD2, they're also actively involved. But if this is restricted to EU countries, then maybe starting January 1st next year, this list may get smaller by one. So here are the major links. That also includes the live demo that I just showed you. So all the DSS framework demonstrations and the download of the Java FX standalone application can be found in those places. There's also a Twitter handle if you want to follow the EU account on eGov. The GitHub repository with the latest version of the DSS framework, and some additional references to the underlying technologies, especially Bouncy Castle for Java, Apache Sanctuario, or Apache PDFBox. Some of them, especially PDFBox, are one possible flavor of PDFs, and if you want to use very specific features of either OpenPDF or PDFBox, you can switch the implementation. That's the beauty of open standards. But then you may face certain restrictions if you're using a feature that only PDFBox or only OpenPDF supports. But beyond that, they're perfectly interchangeable. Okay, that brings us to questions.
Oh yeah, there is a question now from Armel. How different is this AS2 standard?
Different to what?
How different is this? Maybe to AS2 standard, I guess. And then there is one more remark. AS2 applicability statement 2 is a specification about how to transport structured business-to-business data securely and reliably over the internet. Security is achieved by using digital certificates and encryption. So I guess the question is how different is the DSS framework to this AS2 standard?
I guess it refers to the applicability statement 2. Is that correct?
Yes, applicability statement 2, yes.
Well, that basically, it deals with electronic data interchange. So you can definitely use digital signatures in that process. So you can use any of these mentioned signatures, especially EDI and others. They're sometimes still very heavily relying on XML, although in a few cases JSON may also become more popular. But if, for example, you have EDI and you exchange documents that are XML format, like EDXML, then you would normally apply the XML flavor XAdES of the digital signature in this case. So it can be applied inside an ES2 network and data inter-exchange. So those standards are for the electronic signatures. They are the same. You can also apply something else and not use the DSS framework. So for creation of the signature, you can create it with .NET or any other platform, but the signature format and structure itself and the protocols, these are standardized. So you will also use that regardless of whether you're in an HL7 health exchange setup or in AS2, the signatures would be the same. Yeah, if there are no other questions, of course, you can reach us on Twitter.
Thank you very much for attending the session.
Thank you. Bye-bye.